Greetings, this is Artie from Artifact Electronics. Today we're going to have a look at a Tektronix Type 547 oscilloscope. These were made from the mid-60s to the mid-70s. They are very heavy. And the way I found this was the other night I was coming home and all of a sudden the skies opened up and it started to rain like there was no tomorrow, and it was already dark and I couldn't see anything. Getting afraid of hitting Noah's Ark. So what do? You seek shelter, and there was a nearby thrift store conveniently located to provide me with shelter. So I pulled in and started walking through the store and waited for the rain to slow down a little bit. And I saw this sitting on a shelf, and I've never seen a Tektronix scope at a thrift shop. I'm sure they appear there, they get old, they break, people just kind of get rid of them, but I personally haven't. So I looked at this guy, and it was pretty heavy. The first thing that put me off was it was tagged at $65. There are like three tags, one here, one on top. They all said 65, and that's probably not a bit too much, but way too much. But curiosity got the better of me, so of course I picked it up, carried it over to a test station, which is really a kind of a small bench with some AC outlets nearby. It did come with the proprietary power cord. I took it over there, I plugged it in, and absolutely nothing happened. I checked the fuse. It looked good, but it's a slow blow, so you can't really visually check it. The thing didn't work. But while I was looking at the back of it, I glanced at another price sticker, and that price sticker said $25, which brought the whole thing down to earth. And so I loaded it into a cart and took it to the cashier. She argued with me for a while because her logic was there are three stickers saying $65 and there's one that says $25. Ergo, the scope must be $65. But after a short debate, she rang it up at $25, and I carried it out to my car. So of course the first order of business was to check the fuse, and it's over here. And well, we all know what a fuse looks like, but yes, it's a slow blow, 6.25 amps, exactly as specified down here. So and it looks good, and it is good. So not a problem with the fuse. And another thing we can see is there's a rather large fan in here, and I think the filter was replaced with just a piece of thin foam, which I'm gonna have to have a look at that. Just two nuts holding the cover in place, and they're not very tight, so they obviously have been removed. Oh, and here's the other price sticker I found, if I can get it to show up, and that's the one we argued over, but that's what I got it for. So we can see somebody kind of removed this thing, well, or tried to remove it. They just took off two screws and bent it out, and it looks like the fan doesn't turn very freely here. And I've already looked at the service manual, and it does tell you that the fan needs to be lubricated every 3 months. Now, there was a sticker in the front that basically showed us that the next required calibration was for October 1985. So yeah, this thing's probably been sitting for a while, and the fan's all gummed up. And I'm sure that several people, I wasn't the only one who plugged this in when we were at the store. So I guess we might as well try to see if we can power this thing up. Well, I'll just try the same thing as in the store and see if it's still completely dead. So I got it plugged in, and I was originally thinking of bringing it up on the Variac over here, but since this thing's been in the store and probably several people have already plugged it in and turned it on, well, I might as well just turn it on. I don't really think I need to use the Variac, but here we go. Yeah, well, the fan's turning. Let me have a look at the front. That fan needs to be lubricated, right? And maybe when I was in the store, I didn't really hear that because nothing had lit up in the front, and that still is true. But I think the first thing I should do is figure out how to lubricate this thing and getting it to turn smoothly at least. There's some very meager instructions in the service manual on how to do this. So let's have a look inside. The picture in the manual about oiling the fan was not very clear. So what I did was I removed the blade, and followed by removing the frame that holds the fan into place. So I got access to the fan, and it looks like, the text says oil the fan bearings, and that would be right here. Except, of course, this thing is horizontal when mounted, and you'd either have to put the scope on its front in order to get the axle to point straight up, or I thought it was probably easier to remove it and lay it down. So now we could go ahead and just oil this part, and this way the oil won't just drip off, but it'll hopefully actually seep into the bearings, and we'll see if that makes a difference. Now again, to look at this, if I turn it on now, we can see the shaft barely moving, very slowly. And yeah, that was one revolution. And it is pretty hard to turn. So let me get some light machine oil, like for use for sewing machines, and see if that does anything. So here's the machine oil. It is made for sewing machines. And what I'm going to do is just apply a few drips, because there's not really any access holes or specific lubrication holes provided for the bearings. So let's put that in and clean up the overspill a little bit so it doesn't get flung all over the instrument. And see if that makes any difference. Okay, at least it looks like it came up to speed. So yeah, over-oiling isn't good. And it still doesn't turn very smoothly, but it turns a lot smoother than it did before. So I'm going to give it a few more drops, and let the motor run for a while, see if the oil works its way in. Yeah, looks like it's starting up right off the bat now. So let me just let it run for a while, and then I'll put the frame back in and we'll see if it's actually able to turn the blade properly. Alright, I finally got it back together again. Putting in the fan motor and the fan motor frame and all of that turned out to be a bit of a puzzle. Of course, I hadn't paid attention when I took it apart, but finally it went back in. I cleaned things up, the fan blades, reinstalled it, and kind of straightened out the grill and added the missing screws to it. So let's see what it does with the blade installed. And looks like it's coming up quickly. And it's moving air. Great. So let me go ahead and replace this piece of foam with something. I think it needs to be a little bit thicker, and put the frame back on, and then we can start paying attention to the front. I fully reassembled the cooling fan assembly and put everything back in place on the back. One thing that puzzles me a little bit right now is why it was acting like it wasn't working at all in the store. And I think there are three factors involved in that. The first one is when we looked at the fan earlier on in the video, I think it was pretty clear that that thing was rotating at about half an RPM and emitting a bit of a 60 hertz buzz, but because of ambient noise in the store, I probably couldn't hear it. Second of all, there was no activity on the front panel whatsoever, including the power light. But then I looked to the schematics and I found that this thing has a relay-driven delay circuit that takes approximately 35 seconds to enable the operational part of the scope. And that would explain why none of these lights worked. It doesn't explain the power light, but why none of the activity lights came on, and it didn't give any signs of life. So the delay part just kicked in, and now we've got to wait for it to warm up a bit. And what I'm getting is, of course, with the crappy camera I'm using, it's not showing the traces in their full glory, but what we're looking at are typical HP high-quality razor-sharp traces. Both channels are set to ground right now. Doesn't mean much. We need to test it with actual input signals or use the calibration signal, but at least it looks like the power supply is working and that the entire CRT subsystem, including the HV, is also in good shape. But now we've got to find out if we can trigger and show some actual waveforms. But first, let's fix one of the things that's probably really easy to fix and is really annoying. And what I was referring to is the power lamp. Well, that's going to be fun. Let's see. So we take the cover, which just screws off, and then using a specialized bulb removal tool, it's a bayonet base, so you just turn it like an eighth or a quarter turn and it comes out. Having a look at the lamp is, yeah, there's a lot of discoloration. If you look at it real close, one of the filaments is hanging in the air, so the bulb is gone. It's a type T47, and I just so happen to have not one, but a bag full of them, because these are commonly used in older pinball machines. So we insert the new one in the removal tool, turn it till the bayonet goes in, and success right off the bat. It is kind of bright, but let's put the jewel deflector on here. And we now, power light's actually red, but I think it's so bright the camera's showing it as white. And here's what the scope looks like. And as I said, there's some activity here, but I still haven't figured out how to use this, so let's put a signal into it and see what that does. So before actually showing the signal, I messed around with it a little bit, and I did find a problem already, and that is the vertical position of both traces. I mean, we can move this thing up and off the screen, but it only goes down this far. That is the first trace, and the second trace pretty much reacts the same way. It only goes down this far, but it will go off the top of the screen. So something here is out of kilter, and probably the first step would be to check the power supply voltages, and we probably need to clean some tube sockets too in here. Well, two pins actually, but let's have a look at the power supply voltages first. Well, let's measure some voltages, starting with DC. You're looking at the bottom of the instrument, and this is the regulator board over here, and the service manual tells us that the first pair of contacts should be supplying 350 volts DC, and they're pretty close. The second pair should be 225 volts. That's also good. The third pair of contacts should be 100 volts, less than 1% off. And the fourth pair of contacts is minus 150 volts. So it looks like all the DC voltages are right on. Let's check for ripple now, starting with the 350 volt supply. Well within spec. Moving on to the 225 volt supply, also in spec. Going to the 100 volt supply, also good. And finally the minus 150 volt supply. That is also good, considering that this scope's 50 years old and it sure looks like the main electrolytics are original. They are performing rather well, but as it should be obvious to most of you, they need to be replaced. They're 50 years old, and I don't care what the voltages say, both DC and AC. These are old caps, and they are going to have to be replaced. But with that said, since the power supply looks good, let me go on and pull the tubes, clean the pins, dust them off, and put them in a tube tester and see what that reveals to us. And yes, that horrible ambient noise you're hearing is coming from the fan. The fan's running really well now. When I first turned it on, it hiccuped every so often and changed speed, but it is running constantly now. I replaced the filter. Well, I put a piece of foam in there, fixed up the frame, fixed up the grill and everything. But it is a 10-inch diameter fan, and what I didn't mention before was you shouldn't only be careful with high voltages inside of this, but keep your extremities away from the metal blades of that fan, because that will hurt really bad if you get too close to those blades. Well, some time has passed, and during that I pulled all of the tubes, cleaned the pins, and stuck them into the tube tester. You're looking at the left side of the instrument, and one of the nice things they did here is that this whole panel swings open, giving you a nice clear view, well, giving you access to everything. As you can see, there's the tube complement both on the bottom of the chassis as well as on the back side of this, the swing out chassis, and also on top over here. I didn't really find anything untoward, except that the instrument has three 12AX7 tubes, and all three of those showed up as weak. Not very weak, but they were weak. And two of those tubes are in the power supply circuit, but we just looked at the voltages and those are fine. And that doesn't really surprise me because pretty much everything in this instrument is over-designed. And I think the power supply just laughs at those weak 12AX7s, as you could see from the measurement results that we just got. So let's have a look at the other side. Here's the other side of the instrument, obviously much more sparsely populated with tubes than the other side. And I mentioned that all three 12AX7s were weak. Two of them were in the power supply section, which doesn't seem to affect anything, but the third one over here is sitting in the trigger circuit, and the trigger circuit may not be as tolerant of weak tubes as the power supply is, so I replaced that with a tube I had, and that tested good in the same tester, so obviously it's higher performing. And other than that, as I was working around, I was trying to pull out the plug-in and see what was on the plug-in. And I noticed, you can see over here, there's a switch. Let's see if I can get a little bit closer to that. And what that switch does is it detects whether there's a plug-in in there or not. And when you pull out the plug-in, watch the white pin at the end of it. That thing is released, and what it does is it depresses a small contact switch over here, and I guess that tells the rest of the electronics that the plug-in is gone, which in this case is a dual vertical amplifiers. And what it's supposed to do is, I guess it centers the beams so they're not all over the place. Now what I found was that when it was pushed in it was fine, but when you let go of it, and it seems to be, see, it's still not clicking back into place correctly. Now it is. But it was basically getting stuck halfway and never closing that switch. Now that's not going to affect everyday operation, because if the plug-in is inserted, then this is pushed in and the switch is open. But, well, I fixed it by taking it out and cleaning it, and I did have to use a little bit of lubrication on the plastic plunger here where it meets the metal, because otherwise it kept getting stuck. And I think when I tried it originally it still was getting stuck, but it seems to work now. But anyway, pulling out the plug-in, there are no tubes you can see immediately, but looking at it more closely, where did you go? Okay, you can see it over here. There are two tubes in there, but they look they look like this. They actually look like oversized transistors, and there's two of them in there. But they're actually called nuvistors, and they're actually tubes in metal cans, and these are sitting in the vertical amplifier section, one for each channel, and they both tested weak. And that in itself is a bit of a problem. Now they're not dead, they're just they're just slightly weak, but I do not have replacements for those right now. So if there's any kind of problems with vertical deflection in this, I will immediately blame on the Nuvistor and its brother, which is hiding behind him somewhere, because they are weak, and I'm going to have to find replacements for them. Tech used these widely in their scopes, so let's see what I can come up with. But for now, we may expect some degradation in the vertical deflection, which may have something to do with when we saw that the vertical adjustment, the position, was unable to position the beam below, or make it disappear off the bottom of the CRT, but it was able to go off the top of the CRT. Now I looked into that, and I found something that may actually imply a somewhat serious problem. And what I found was there is an adjustment. There is a pot here. Where did you go, pot? There you are. And that pot is labeled, come on. So it's right here, and it's labeled vertical DC balance. And looking at the schematics and the service manual, I did an adjustment on it, and I was able to get the beam to be centered when the adjustment knobs are very near the center of their travel. But it turned out I had to turn them about a quarter turn, and so I looked at some of the other pots, and what my fear is I think somebody went in here and started playing the "I wonder what this pot does" game, and went ahead and turned all the pots and looked at the screen, and they weren't marked, but you know, sometimes people do that. They go in and say, oh, it's sitting at about 1 o'clock, so let me turn it back and forth a little bit, see if it affects anything, and then turn it back to 1 o'clock. Well, these are single turn pots, and you can never, without marking them, even when marking them, you can never get them back in the same position. So if I'm right about that, if somebody has gone in and messed with all of the pots, I'm going to have to go through a full calibration sequence to even have a hope of getting this thing back to working correctly. But before going up that path, now that we've cleaned all the tubes and everything, let's power it up and see if at least we can put some traces on the screen. By the way, what you're looking at is this tube over here. Looked different than all of the other ones. I think this was the only tube that had been replaced because it was clean. I didn't even have to clean this thing up. And it's a Raytheon, made in Japan, and it doesn't match anything else as far as tubes in this instrument. So I think all the other tubes were original. Of course, I replaced, oh, you cannot see that, but I replaced this one over here, which was a 12AX7, and this one tasted good. So so that's about as far as we're going to go right now, knowing that there's a potential problem with the weak Nuvistors in the vertical amplification section. But let's see what we can get out of this. Okay, I put it all together. I put all the covers back on in hope of reducing the infernal fan noise, but it hasn't made a great big difference. But after quite some effort, you can see I was able to display two traces. The first trace on top is the output of the calibration circuit, giving you a square wave. And the second trace is fed by my function generator with a triangle. Now, keep in mind this is a single beam instrument, so obviously there's a lot of trickery involved in showing two traces. and I think I had to cheat a little bit because I couldn't get a stable display until I made both signals very close in frequency, and then all of a sudden things started to stabilize. The triangle is a bit jittery, but I'm going to have to hit the operation manual because I don't fully understand yet. It's got two time bases, A and B, and B is labeled main, and then it's got the two vertical channels, and basically right now it's in alt mode on the vertical and in alt mode on the time bases. And when I go to anything else, it's really difficult to get things to stabilize. So I'm going to have to read a little bit more and see what the operating manual has to say. And probably looking at the schematics, tracing the schematics a little bit more is probably going to be a better explanation for me of how all of this stuff is multiplexed together and what is supposed to do what. Again, the camera doesn't do the traces justice. They are, in real life, very sharp and very beautiful. And but I really don't know if my difficulties in getting this display is due to user error or ignorance, or the aforementioned problems, the weak navistors. And of course the laundry list of things to be done here is one thing I didn't mention before. I need to clean and lube all of the pots and switches. For instance, there's a brightness control here that lets you increase the brightness of the second trace relative to the first trace. And that thing is so gummed up. I mean, I got to take pliers to that thing to be able to turn it. It actually does work, but if I'm going to use pliers on it, it's going to totally strip this knob. So yeah, things need to be cleaned and lubricated. All the electrolytics need to be changed in here. I need to find the two replacements for the navistors. And once all of that has been done, I need to go through and do a full calibration on this. Calibration is described in the service manual. There's still one or two pieces I'm missing, external stuff needed to do the calibration. But that's essentially the laundry list of what steps I would need to take next to bring this back into full operating condition. But at least we got it. I think we've proven that it can show two traces in a stable manner. It's been running for about half hour in this display, and the display hasn't disappeared, or weird things haven't happened, or sparks haven't come out the side. By the way, that fan's working well. This is like a space heater. I mean, there's pleasant warm air coming out of this. Well, it's pleasant now. In another 2 months it'd probably be unpleasant, but it seems to be working, but it does need quite a lot of help to get rid of decades of neglect on this. Anyway, I hope you learned something, or at least enjoyed this. So go ahead and mash the like button and make sure to subscribe. I can't promise about when I'm going to get to continuing the work on this. It's much more exciting to get something fresh that's not working and just diddle around with it till you get it to do something, and the other stuff kind of becomes boring. But I will eventually get to this. This is a piece of test instrument history. It's a really nice scope, and it's not going anywhere. So thanks for watching. Take it easy, and we'll see you next time.